Hey, it's Mr. Estrada here, and in this video, our learning target is I can apply the angle-side relationship theorem. Okay, so before I even get started with what the angle-side relationship theorem is, I want you to take a look at this triangle that I sketched on GeoGebra. And I'm going to manipulate the triangle a bit, and I want you to notice the relationship between angle C and the opposite side, which is AB. So watch what happens as the angle gets bigger to the side across from that angle. So angle C is getting bigger, and what happens to the side opposite from it? It's getting bigger as well. Did you notice that? So if I make the angle smaller, the side gets smaller. If I make the angle bigger, the side opposite from that angle gets bigger. All right? All right. Now I went ahead and I added the different measurements for the sides and the rest of the angles because I want you to notice something else. And this is an application of what we just saw earlier. You're going to notice, and let me just manipulate this a little bit more. And let me just move that up a little bit just for viewing purposes. Okay, you're going to notice that the biggest angle is angle A. It's 106.13 degrees. And what I want you to notice is that the longest side is across from the largest angle, which makes sense if you think about it, because what we saw earlier was that the bigger the angle, the bigger the side across from it. All right? So all this leads to the angle-side relationship theorem, which says the longest side of a triangle is opposite the largest angle, and the shortest side of a triangle is opposite the smallest angle. Just a little word on opposite. Opposite means across. Okay, so that's very important. Opposite means across. So the side opposite angle B, so here's angle B, the side opposite from it, across from it, is AC. The side opposite angle C, so here is angle C, and the side opposite from it, across from it, is AB. The angle opposite side BC, so here is side BC, and let me erase all this just so it doesn't get too cluttered. Here is side BC, and the angle opposite from it, so you wouldn't go this way because this is not an angle. The angle opposite from side BC, you'd go this way, is angle A. All right? And what we've learned, right, through this GeoGebra manipulation is that the longest side is opposite the biggest angle, and we see that here. And we'll also notice that the shortest side, in this case the shortest side is 6.31, is across from the smallest angle. All right, so that's the, excuse me, I said triangle inequality theorem earlier. I didn't mean to say that. I meant to say angle-side relationship theorem. Okay, so this is the angle-side relationship theorem, and let's work out some examples. Example 1 says, in a scalene triangle, ABC, measure of angle B is equal to 45, measure of angle C equals 55. What is the order of the sides in length from longest to shortest? So I'm going to go ahead and just sketch a scalene triangle, and I'm going to label it A, B, and C. And what I know is that angle B is 45 degrees, so I'm going to write 45 degrees for angle B. And I know angle C is 55 degrees. And by the way, you're probably noticing by now that this is not drawn to scale. All right, before I move on, I need to figure out what the measurement of this missing angle is. So I know that they have to add up to 180. So 55 plus 45 is equal to 100, so that means angle A is 80. Okay, so the question is, what is the order of the sides and length from longest to shortest? So if we go back to the angle side relationship theorem, we know the longest side of a triangle is opposite the largest angle. So what's the largest angle? The largest angle is 80 degrees. So that means the longest side is BC. So BC is longest side, or is the longest side. The longest side. Okay, if we're going in order from longest to shortest, then the next one in that order would be side AB. So AB is the, and we'll just say medium side. And then the shortest side would be side AC. AC is the shortest because it's across from the smallest angle. So in order from longest to shortest, it's BC, AB, and then AC. So the answer is choice 4. BC, AB, then AC. Alrighty, let's try another one. In triangle ABC, measure of angle A is 95, measure of angle B is 50, and measure of angle C is 35. Which expression correctly relates the lengths of the sides of this triangle? So all of these choices are listed in order from shortest to longest. Shortest to longest. Right, because this says AB is less than BC, BC is less than CA. Sorry about that. So they're all listed in order from shortest to longest. So I have to sketch the triangle, label it, and from there I'll be able to figure out what the correct order is. So I'm going to call this A, B, and C. So A is 95, B is 50, and C is 35. So the shortest side is across the smallest angle. The smallest angle is 35. So the shortest side is AB. And by the way, in case you're wondering, this is not drawn to scale. So the shortest side is AB. The next one, going in order from shortest to longest, would be side AC, because it's across the 50-degree angle, which is the second largest angle. So AC would be the next one. And then the biggest side would be side CB. So side CB. So this is the correct order: AB, AC, CB. So we could say AB is less than AC and AC is less than CB. CB is greater than all of them. So I know the answer cannot be choice 3 and it cannot be choice 4. It's between choice 1 and 2. And the answer is choice 2. Okay, for our last example, it says in triangle ABC, AB is equal to 7, BC is equal to 8, and AC is equal to 9. Which list has the angles of triangle ABC in order from smallest to largest? So again, I'm going to go ahead and sketch a triangle. And I'm going to try to draw this one to scale. So I'm going to make this AC, and this will be B. So it says side AC is 9. By the way, right, these are all sides. These all represent sides. So side AC measures 9 units, side BC measures 8 units, and side AB measures 7 units. AB is 7, BC is 8, AC is 9. So we want to go from smallest to largest. So smallest to largest, well, the smallest angle would be across from the 7. So the smallest angle is angle C. And then the next one, going in order from smallest to largest, would be the one that's across the 8. So across from the 8 is angle A. And then finally, the biggest angle would have to be across from the 9, the side that measures 9, and that would be angle B. So the answer is choice 4. And if you wanted to write this in equality form, you could write it like this. You could say angle C, is less than angle A, and angle A is less than angle B. Forgot my less than sign. Let me redo that. So angle C is less than angle A, but angle A is less than angle B. All right, that concludes this video. I hope this helps. Take care.